Hello, this lesson is about Coulomb's law. We're going to cover some definitions and some examples. Coulomb's law is all about electrostatic forces, and we can express this force here by this formula, where we have the force on particle I due to particle J is the proportionality constant times the charge of particle I times the charge of particle J divided by the distance between the particles squared times the unit vector in the direction from J to I. And this force is actually the same, but in opposite direction of the force on particle J due to particle I. What we need to know from this is that the force is proportional to the product of the charges and that it's inversely proportional to the square of the distance between them. For example, if we have two particles with the same charges, right, positive charges for example, they're repelling each other, but if they have opposite signs, they're attracting each other. So this force here can be expressed in terms of the charges and the distance square, the square of the distance between them. We also can apply the superposition principle to Coulomb's law. Well, it means that the force acting on a particle, if we have a system with more than two particles, is actually the summation of all the forces from all the particles around it. Well, let's take a look into this example here and try to find the modulo of the resultant force on our particle Q here. We know, let's assume that the blue particle has a positive charge and the orange particles have negative charges, and their modulo are the same, and the distance here between them are the same also, and everything here is symmetrical. So we know that the force acting on Q due to particle Q here, the blue particle, sorry, is actually repelling, a repelling force, and the force from this other particle here is actually attracting. So we have a resultant force in this direction, adding these two vectors. If you have any doubts on how to add these vectors, you can just take a look into our vectors basic operations video. So going back here to the example, we know the modulo of this force can be expressed actually, because everything here is symmetrical, in terms of F1, because well, they have the same modulo, F1 and F2, but in different directions. But in this case we want to know only the modulo, so we know that the modulo of the resultant force is 2 times F1 times the cosine of this angle. And we know that this angle here, if you think this is a right rectangle, we know that this angle, the cosine of this angle, is actually D divided by R. So we have this here. Rearranging, just isolating F1, we have that the modulo of F1 is the modulo of the resultant force times R divided by 2D. Let's apply Coulomb's law now to F1, so the force of the blue particle acting on our particle here. So you know that the modulo of this force is the constant K times the charges of both particles divided by the distance squared. We know that F1 actually equals to this, and we can isolate F, the modulo of F, to find its value. We can also express the same thing in terms of small d and capital D. Remember, this is a right triangle, so applying Pythagoras theorem, we have this expression here, the final expression. The for the module of the resultant force on this particle due to these two other particles. Alright, now it's your turn to test your knowledge. We have these two particles here. One of them has a charge of positive 3.37 microcoulomb and the other one has a charge of negative 8.24 microcoulomb. And the resultant force between these two particles here is 0.0626 Newton. So I want you to determine the separation distance between them. So think about it, do your calculations, and comment in the comment sections your answers. Thank you.
Physics doesn't have to be hard. Subscribe to our channel and learn with the geeks.